If you vibrate at the natural frequency of the air around you, your cells will be in an excited state, allowing you to break through that wall and leave the bond behind on the other side. The Flash isn't just capable of running at lightning speed, he can also phase through walls. But it's not just the Flash who can do this, many other superheroes have the same ability. So, are these superhero powers scientifically plausible? Of course, no human can just phase through walls without destroying them. But it's a different story if you look at it from the perspective of atoms or molecules, because something solid isn't always what it seems. That's why before we begin, get your minds ready and prepare your faith, because we're about to dive into a discussion that could blow your minds. Let's start this discussion with a simple question. Why can you pass through water but not through ice, even though you know both come from the same substance, water? If your answer is simply that ice is denser than water, there's something strange you might not have noticed. Isn't ice supposed to float? If ice is denser than water, shouldn't it sink? What you need to know is that water has a unique property called the anomaly of water. Normally, when a liquid is frozen, it becomes denser than its liquid form, but this doesn't happen with water. When its temperature drops below 4 degrees Celsius, actually becomes lighter. As a result, the coldest part rises to the surface, causing ice to float. This means that when water turns into ice, it actually becomes less dense. This shows that something solid or hard isn't necessarily due to being dense or compact, but rather because of something else that makes it hard. To help you understand, we'll discuss atoms and molecules. By understanding this, you'll grasp why something can be solid, and eventually, this will explain how the Flash can pass through walls. Everything physical in this world is made up of atoms. However, atoms cannot function on their own. They need to combine into building blocks called molecules. You can think of them like Lego pieces. Of course, these Lego pieces aren't all the same. Some are long, some are short, some are square-shaped, others are L-shaped, U-shaped, and so on. The same goes for molecules. Molecules are the fundamental building blocks that give each thing its properties and identity. For example, it's molecules that make water, make wood, and make iron what they are. Essentially, everything we see and recognize in this world is made up of molecules that give them their unique characteristics. You've probably heard that water is also called H2O. It's called H2O because that's the water molecule, made up of 2 hydrogen atoms and 1 oxygen atom. These atoms are bound together by what's called a covalent bond. This bond is very strong and keeps the water molecule intact, whether it's in the form of ice, liquid, or vapor. So, what happens to water molecules that allows them to change into ice, liquid, or vapor? Take a closer look at its structure. The H2O molecule forms an angle where one side contains 4 electrons that are not paired with any other atoms. This makes that side more negative compared to the other side. As a result, the water molecule has positive and negative poles, much like a magnet. When these water molecules are close to each other, they can stick together, forming bonds known as hydrogen bonds. This is what makes water appear to be united. However, hydrogen bonds are not as strong as covalent bonds, and when in liquid form, the water molecules are always moving, causing these hydrogen bonds to easily break. This is why water can easily disperse and why your hands can easily pass through it. However, the situation is different when water turns into ice. You know water turns into ice when it's cooled in the freezer, and that happens because the freezer can lower the temperature to 0 degrees Celsius, which is water's freezing point. But the question is, what exactly is temperature? You might think of temperature simply as hot or cold, but here's a definition you might not hear often. Temperature is the average kinetic energy of the vibrations and collisions between atoms or molecules. It's important to understand that molecules are always moving, even in solid objects. The speed of this molecular movement is what you actually perceive as heat or cold. So, what happens in the freezer is that it absorbs all the kinetic energy from the water, causing the water molecules to slow down more and more. When the temperature reaches 0 degrees Celsius, the water molecules come to a complete stop. At this point, the hydrogen bonds between the molecules become stronger than when the molecules were moving, which is what makes the ice harden. You can see in the following animation how the arrangement of water molecules changes when it turns into ice. Notice how the water molecules, which were once moving freely, become rigid and bond together to form a hexagonal structure. What's interesting is that this hexagonal arrangement actually makes the water molecules more spaced out compared to when they are in liquid form. This is the cause of the anomaly where ice becomes lighter. Now, what does this phenomenon have to do with the flash's ability to pass through walls? From the previous explanation, there are two key points. First, something is solid not because of its density, but because the bonds between its molecules are strong enough. Ice becomes more solid than water because its molecules bond more tightly. The second point is that the more solid an object is, the harder it is for its molecules to move. The change from being solid to solid, or vice versa, is called a phase change. Do you remember the name of the flash's ability? Yes, it's phasing, or phase change, just like when ice melts. While we don't actually see the flash melt, the point is that the flash accelerates the movement of his body's molecules so that his body undergoes a phase change from solid to not solid. How does he do this? By vibrating. Why vibration? Well, you need to know that there are 3 types of molecular motion: vibration, rotation, and translation. Vibration is the oscillation of atoms within a molecule, rotation is the spinning of the molecule, and translation is the shifting of the molecule from its position. In a non-solid state, like water, molecules can freely move and perform all 3 motions: vibration, rotation, and translation. But in a solid state, like ice, molecules can only vibrate. Here's an example of molecular vibration when water is still ice. But if these molecules gain energy, like when ice is taken out of the freezer, the vibration gradually becomes stronger. Over time, the bonds between the molecules become weaker until they eventually break. This is what the flash does. He accelerates the vibration of the molecules in his body, causing the bonds between them to weaken, and his body becomes less solid. At that moment, the flash can easily slip each of his body's molecules into the molecules of the wall, just like water seeps into a wall. Once he's through, he slows down his vibrations and his body becomes solid again. That's how the flash can phase through walls. However, the flash's method is inefficient because vibrating requires a lot of energy, while vision can do it without any vibration at all. Calmly, he walks toward a wall and suddenly phases through it as if the wall isn't even there. Wait, how is that possible? Now let's move on to the next topic, quantum tunneling. But we'll cover that in the next episode. But before we end today's discussion, let's return to the topic of water anomaly. Did you know that without this anomaly, we and all living creatures on Earth wouldn't be able to survive? As we discussed earlier, water becomes lighter below 4 degrees Celsius, so the colder water rises to the surface. That's why in the polar regions, the ice only forms on the surface. If you pay attention, the temperature gets colder the higher up you go, but as you go deeper, the water actually becomes less cold. This is what allows fish to survive even in extremely cold weather. Without the water anomaly, the fish would freeze to death. In fact, the ice layer above acts as a protective shield, almost like a blanket, because this ice layer can't be penetrated by the weather above it. That's for the fish, but what about humans? Why do the North and South poles exist for us? Because those two poles help keep the Earth's temperature stable. It's because the vast ice layers reflect all the harmful solar radiation that can be dangerous to humans. Without the ice, the poles would burn up. That's why water was created with this anomaly.